So, hello, my name is Gregor Schumacher, and I'm talking about how APIs and cloud can help learners about AI adoption. I'm part of the API Days in Munich and happy to be here. In my main job, I'm a tech innovation lead at Riverty, and as such, I'm helping my company to adopt new technologies faster. I wrote a book about public cloud transformation. It's a business book, also about adoption. So adoption of new technologies is kind of my core knowledge. Riverty is a family-owned, Bertelsmann-owned enterprise, around 700 million of revenues, mostly in Europe. We do financial services. So you have noticed that there is all the crazy talk about Gen AI. Gen AI is about to transform the world. It'll replace our jobs, all human jobs. It's insanely good. It changes everything. You know all the stuff. And in fact, if you look at what's happening out there, we are on the path to disillusionment. Meaning, we go through the Gartner hype cycle, and if you look at it, we are right now here. So 2025 must probably be a little bit lower here, even. And the question is AI not as big as we thought? So you've seen all the buzz around it, and you now see we are on the path to disillusionment. What's going on? And if you look at past hype cycles from Gartner, you see even cloud computing was on the path down there, and online video even was. So there seems to be a kind of pattern. Even if you look back 100 years ago, electric motor once was a hype too, and also got through this trough of disillusionment. So all of these technologies have held their promise. Why does every tech wave now have to go through this valley? And this is quite easy to explain if you look at the electric motor. Before the electric motor arrived to textile manufacturing, these factories were built around the steam engine. So on the left, you can see the steam engine per factory. You had one huge steam engine with lots of power, and all the power was transmitted through axes, you see them here, and belts to the machines. So every machine was following the same beat, the beat of the steam engine. Now, there were salesmen from electric engines coming to these companies and said, hey, I have this electric motor, why don't you use it? And the factory owners, they simply replaced the steam engine with the electric engine, and then noticed, oh, well, there's hardly any value coming from the new technology. But then electric native companies popped up. So if you look at an electric native company, it looked roughly like this. So some smart manager who didn't know about steam engines just thought about factories around and built them around electric engines. So on the right, you can see a lady with an electric engine, and there was electric light. So the factories that followed the steam engine factories were optimized on electricity. And then they could, of course, add lots of value. They could include the value chain afterwards. They could individualize more, etc. Same pattern was true for cloud. So if you look at cloud and classic cloud lift and shift migrations, people did these lift and shift migrations and then noticed, oh, we moved all of our servers into the cloud, but nothing appeared to have changed. Just maybe the bill, because usually if you do lift and shifts in cloud and don't change anything else, you're going to pay more than you did before. What I said when I was responsible for these organizations, I always told them, well, what you do is you apply the new technology, but you use the old operating model. So using a horse and car metaphor, you see You take the new generation of technology, you use it, it brings some value, some specific value, but you don't get rid of the old one. So you have one horse rider, one car driver, you still have the horse, plus you have the new technology. And you can see there isn't much additional value coming from that kind of transportation. So if you look at companies, this is a slide from Benedict Evans. Corporates are stuck with their cloud transformation, mostly because they struggle to adopt to the specific needs of cloud. So organizations in general struggle to adopt new paradigms because they are optimized on the old paradigms with their operating model, with their infrastructure, with their kind of governance. And if you look at AWS again, or cloud again, AWS was invented in 2006. There was around a time frame of roughly 10 years the world required to figure out what cloud native means. So how the operating model that fits best to the cloud would look like. Now we know it's agile, DevOps, microservices, product thinking, automated testing, containers, etc. And the market success patterns connected to cloud native are SaaS, software as a service, freemium services, micro advertising like social media. So all of this stuff was only possible because of the cloud technology. Cloud technology changed the paradigm of the operating model. You see at the market success side here, companies who adopted to cloud native, they were super successful. Companies who didn't, like Atos, for example, remained stuck in their old paradigms and then eventually filed bankruptcy. Same counts for API as a product. I remember I once had the dream to turn our company into an API as a product or API-driven company. And I noticed there are so many changes we all have to go through to be an API as a product, an API native company. For example, we needed to see developers as a target group. We needed to have good developer portals. We needed to optimize developer experience. We needed developer advocates, plugins, partnerships, community management, all that, what makes API as a product company successful. I just didn't manage to create those days in my company. So we didn't succeed very much with APIs, whereas companies are optimized for APIs like Contentful, Twilio, Stripe, Shopify, they succeeded. So the question we now have is, AI is a new generation of technology. It's a new tech wave approaching to companies. But what most of us do is just applying that new technology in the old method, in the old operating model. So the question is, how would an AI native company look like? And what are success patterns around AI natives? How do we have to organize our companies around this new technology so that we will be successful in the new markets? So the general learning now from API and cloud is Gen AI makes us rethink operating models and market success patterns. We will not be successful with Gen AI as a new technology if we don't adopt our operating model to it. So the question is, how could that look like? And I was researching the net, and Satya Nadella, for example, thinks software will be replaced by agents. There's like half a year ago that went viral. He said, there will be no SaaS apps anymore. It's all be done by agents. Benedict Evans says AI is whatever doesn't work yet. When it works, it's just software. So essentially, the conclusion is, well, AI will create even more software. Datran, a big thinker here from Berlin, says software and services will merge. Uli Hohmann, with whom we are in contact with Riverty a lot, says, well, there will be more platform engineering, whereas experiences will be faster. Jeanette zu Fürstenberg, she's an investor into Helsing, says eventually humans will mostly do empathy. And Sam Altman says there will be a 1 person, 1 billion valuation company. So there's lots of talk around AI native operating models, let's say like this. But the too long didn't read is nobody really has a clue. There is a trick though. So we can forecast upcoming changes if we apply first principle thinking. So first principle thinking always tries to figure out what is the underlying core of a change, of a method, of a success pattern. And if you look at AWS, what really made the cloud, especially the public cloud, more successful compared to classic IT infrastructure is these 4 green boxes here. So public cloud is totally automated. Ordering, delivering, billing IT service is fully automated. Because it's automated, you can order super small quantities of it, and you can order hyperscale quantities of it. You have a broad choice that you can directly use, and everything is, in general at least, pay as you go. So you also change the risk patterns and investment patterns. Of course, it's connected to outsourcing risk, which we kind of pay now with our dependencies on hyperscalers. However, companies who organized for these 4 core patterns or core principles, they succeeded. And just give you an example, before there was the cloud, the sales for IT was done like this. So like lots of well-paid people in suits met on expensive trade fairs, invested a lot of transaction time, and eventually they sold one big piece of SAP CRM system for 5 million, including software and IT and product, etc. That is how you did sales in classic IT. How you do sales in modern API and cloud-based IT is like this. So some developer looks up the API reference on the web, integrates, and that's it. This is how you scaled classic IT. So you made a plan, you assumed the traffic you're gonna get, you acquired or you invested into your IT infrastructure. And if due to some error, like in this case, you have more demand for your IT infrastructure than you actually assumed for, then you're gonna have outages. How you scale natively with APIs and cloud is what you could perceive with Kubernetes. So Kubernetes with Pokemon Go was run on Google Cloud based on Kubernetes, and Pokemon Go exceeded the original estimates about usage by, I think, 50x, but they could manage because they were cloud native. So these 4 first principles can explain every change in the operating model, in the market success patterns during the cloud revolution. Question now is, what are the first principles of Gen AI? So how does Gen AI differentiate from natural intelligence? So how does AI differentiate from NI, natural intelligence? And the first big difference is AI is scalable. So as soon as you have an AI that does something that a natural intelligence does as well, you can scale it. You can scale it to the very little amount, just 1 token, just 10 tokens, but you can also make it hyperscale globally. First principle is AI is technically accessible. That means to a natural intelligence, you can only have access just by talking or sending messages, etc. This is not fast. This is not really reliable, prone to lots of misunderstandings. AI, on the contrary, is technically accessible. So you always have interfaces, APIs, etc., where you can communicate properly and reliably towards this intelligence. AI has unpredictable misalignments. That is true. But to be honest, every human has kind of unpredictable misalignments too. I mean, everyone who had some kind of had employees for a while knows, well, you can have these misalignments too. The advantage now of AI is micro-controllable because you can technically connect to it. You can check, you can log and check every tiny little sub-decision that this AI takes. You can have another AI or a classic software checking every step in a reasoning and in a process. So that is one core advantage you have of an AI compared to a natural intelligence too. So looking at human intelligence, seeing the first principles of AI, what does that mean for us? And what can we predict based on that? And I did 5 forecasts regarding AI native operating models based on these four first principles. So first prediction is domain know-how will be turned into reliable automations. That's what we already see today. So for example, there's an automation that helps employees apply for jobs at scale. So you hand in your CV and this automation applies to millions of employers at once. So that's kind of an automation. You have other automations designed to code, so turning Figma visuals into front-end code. You have translation as an automation. So there will be lots of automations across the world. People will try to make these automations as reliable as possible, so as few hallucinations as possible, and usually that goes along with lots of classic software that checks the underlying LLMs. On top of these automations, there will be then more autonomous agents. So if you can be sure, or it's like 99% sure that this automation does what it's supposed to be, for example, designed to code or cancer recognition or etc., you can put agents on it that flexibly depending on the actual intent of the customer or the interdisciplinary team, choose these automations and combine them as it likes. But in order to adopt for the needs of these less deterministic integrations, the APIs that are involved need to change. Right now we have classic APIs, for example, Stripe. This API has a clearly defined scope and feature, and you understand this feature as soon as a developer has understood it. This API is integrated and it does exactly this. But now imagine a world where you have these autonomous agents walking around, having lots of automations as a choice, having an intent. They're going to try to figure out what automation I want to use in which order to reach or to fulfill my intent. So these agents, they will need to have, or they will have this need to understand the full potential of this API, the opportunity, how can I use this automation with this API in combination with other APIs and other automations to fulfill my intent. So there will be more, let's say, discovery features be necessary in APIs. Last forecast, we will need way more sophisticated access management. So now assume you're a big corporate, you have lots of automations. These automations require the specific context you have in your environment. And what I do with this automation depends a lot on the role I actually have and the intent I have. I give you an example. Suppose I'm wanting to know my salary from my HR responsible, and then I'm going to ask him or her, and then this HR responsible can access the information in the system and will give it to me. But suppose I ask the same HR responsible the salary of my boss. The HR responsible will be able to see that salary, but having a proper role-based access management, also understanding the intent of this communication, will not be giving this information to me. But now imagine you have a company with lots of automations that in general could solve the problem, but you don't know, you have to know the intent of the agent in which combination it wants to use which automation to do what. So to cover for that, we'll need to invest a lot into role-based access management that just doesn't the role-based access management of today, but also adds agent IDs, for example, for AI agents, also adding the intent and the purpose, and also the auditability. Oh, there's a last one now. There will be a mesh of bots with governance tasks. So there will be lots of, remember, AI is microcontrollable. There will be a lot of stuff going on at scale. And so we will put we will put a governance bot on every kind of other bot, on every kind of automation as well. My favorite story here is I once tried to trick ChatGPT into creating a picture of Sam Altman. ChatGPT doesn't really want that. And on my way to creating Sam Altman with ChatGPT, I had 2 situations where this governance bot checked what I wanted to do. But then eventually I managed to trick all those 2 governance agents. It started to create Sam Altman, but as soon as his face was becoming clear in this picture, again, the process was immediately stopped. So there was another of these governance agents checking constantly the result against some basic rules. So this is going to happen here as well. Too long didn't read. What do cloud and APIs teach us about AI adoption? AI will go through a valley of disillusionment. So rooted in the wrong assumption, we could make big leaps with AI without internal transformation. AI will yield big benefits as soon as we adopt our operating model to it. So as soon as we build our factories around AI, this operating model will entail many AI-based automations. So there will be a basic layer of reliable automations just covering for specific tasks. And based on these automations, there will be more autonomous agents. But in order to make that work, also the nature of our APIs will change to be a kind of moderator between these automations and agents. So thank you very much. I hope this was insightful. Please get in contact with me on LinkedIn. I'd love to have some chat about these ideas.